Salam sejahtera. I'm Noniana Umping with metric number B092016. This is a lab report presentation for the subject BMMH2303 Thermodynamics for Lab 4 Heat Pump. Okay, before we proceed with our presentation, I would like to introduce my group member. There is Muhammad Hazim bin Husin with metric number B0920100103, Muhammad Daniel Irsham bin Ruslan B0920100318, and Muhammad Lukman Al Hakim bin Yusmar B0920100122. The next slide is procedure. Okay, in this lab, we need to do type of experiment, that is refrigeration cycle and heat cycle. Okay, when we refer to the table 1 for refrigeration cycle, we need to find the value of the temperature for T1, T2, T3, T4, T5, T6, T7, and T8. P1 is a low pressure and P2 is a high pressure in unit bar, and the water flow rate must be in the reading of liter per minute and the power in unit of watt. Okay, same things goes to the table 2 where we need to find the value for T1, T2, T3, T4, T5, T6, T7, T8, lower and high pressure P1 and P2, water flow rate and the power. For the procedure, first thing first, switch on the power supply. Okay, before we change the mode to refrigeration and heat pump mode, we need to switch on the main switch and switch on the compressor. Okay, for the refrigeration mode, we need to switch on the chiller power switch. Okay, we need to wait for about 5 minutes for the temperature average reading in steady state. And after that, record all the data in table 1. Before we change the refrigeration mode to heat pump mode, we need to switch off the main switch and also turn off the compressor. And after that, change the mode to heat pump mode from refrigeration mode to heat pump mode. And don't forget to switch off the chiller power switch. And after that, turn on the compressor. And next, wait for a few minutes, about 5 minutes, before we record the data in table 2, in which we need to wait for the temperature and pressure reading in steady condition. And after that, we can record all the data that is needed in table 2. For both refrigeration cycle and heat cycle, the water flow rate, we can take the reading in the flow meter. And for the power, we can take the reading of the power in a digital screen here.
Bismillahirrahmanirrahim. My name is Muhammad Daniel Irsham bin Ruslan with metric number B0920100318. Right now I'm going to explain about the whole process. As usual, before we proceed with the experiment, ensure all lab technicians will give a lab briefing first about the experiment and lab safety so that the student know how to use and handle the equipment they use during the lab. After done with that, each group will be given a time to conduct the experiment according to the procedure given. We must follow all the steps in the procedure until all the data that we need to measure is obtained and record the data in the table of the result. Once done, all the data have been recorded, the result obtained need to be checked by lecturer before proceed with the lab report. So the first one is experiment 1, refrigeration cycle. The first step is switch on the power supply. Next is switch on the main switch. The third one is switch on the chiller power switch. After that, we must select mode to refrigeration mode, which is REF. Then we switch on the compressor. After that, we must allow the refrigeration cycle to run for 5 to 10 minutes. After that, we must record the data in the table 1. Next, we take the power reading to refer to the power meter. And the last one is we take the water flow rate reading refer to the flow meter. For the experiment 2 is heat pump cycle. The first step is switch off the compressor for 10 seconds. After that, we select mode to HP, which means heat pump mode. Then we switch off the chiller power switch. Next is we switch on the compressor. Then we allow the system to run for 5 to 10 minutes until the temperature and pressure reading in steady condition. Then we record data in table 2, refer to the AQ software screen. Then we take the power reading, refer to the power meter. And the last one is we take the water flow rate reading to flow meter.
اللهم صل على سيدنا محمد. Safety regulations for the lab 4. Wear eye protection at all times in the laboratory. Shoes must be completely cover the foot. No sandals are allowed. Dress properly during all laboratory activities. Long hair, dangling jewelry, and loose or baggy clothing are a hazard in the laboratory. Long hair must be tied back, and dangling jewelry and loose or baggy clothing must be secured. Never work in the laboratory alone. Always have another qualified person in the area. Wearing an iPod or other device that interferes with hearing is not allowed.
My name is Muhammad Azim Hussein and my match number is B0920101003. So today I will explain about the result for the lab heat pump. So we have the data for refrigeration cycle data and heat cycle process data. So we have temperature 1 until 8 and 2 pressure, and we have the power and flow rate. So all the data that we get by the machine. So first, elaborate the process temperature, pressure and refrigerant phase condition of the refrigeration cycle. So the answer is this refrigeration process have 4 stages. Each stage has different process. For the stage 1 until 2, it is compression process which is involve the compressor. The refrigerant enter the compressor as low temperature and pressure saturated vapor and is discharged as a high temperature and pressure superheated vapor. Then for the stage 2 until 3, it is condensation process which is involve the condenser. The high temperature and pressure vapor enters the condenser where it condenses at a higher temperature than the heat sink. The heat moves from the condenser to the heat removal environment and condenses into saturated liquid at a constant pressure and temperature. For the stage 3 until 4, it is expansion process and it involves expansion valve which lowers the pressure abruptly to the original pressure. There is torturing process occurs. The process is assumed to be adiabatic since it repeats and no work is done. For the stage 4 until 1, when the pressure of the liquid is lower, it starts evaporating. The energy that evaporates the refrigerant comes from cooling everything down. As it passes through the evaporator, it be the saturated mixture and leave it as saturated vapor and then re-enters the compressor, this completing circuit. Okay, so for the B, the liquid phase refrigerant absorb heat in the evaporator and change it into vapor by the compressor and rise the pressure and temperature. The refrigerant flow through the condenser inside the door unit and make it high temperature and low pressure. The refrigerant then change it into saturated liquid. Next, the fluid flow through expansion valve and reduce its pressure and also the temperature to cool down and the cycle repeated. So we need to draw the cycle data into the pH diagram. So we do the line from the pressure, and then we need to determine the line that near with the saturated vapor line, and then we plot the point, then we find the enthalpy. So the enthalpy we get for H1, H2, H3 and H4 is H1 is 415 and H2 is 440 and H3 is 250 and H4 is 250 also. So we need to calculate the refrigeration cycle COP and calculate the heat pump cycle COP. COP is coefficient of performance. So first, for the refrigeration cycle COP, the formula is H1 minus H4 divided by H2 minus H1. So we enter the value and we get the answer is 6.6. And for the heat pump cycle COP, the formula is H2 minus H3 divided by H2 minus H1, and also we enter the value and we get the answer is 7.6. So we need to compare the our calculated refrigeration cycle and heat pump COP with both published data, and thus it meet the requirement of COP HP equal to COP refrigeration plus 1. And then we need to explain. So the answer is the COP of refrigerator is 6.6 while the COP for heat pump is 7.6. So based on the data we get, the value of heat pump is more than 1 to the refrigerator. It is required for the formula or theory that published that by the book there is COP of heat pump equal to COP of refrigerator plus 1. So we need to calculate the overall COP. So for refrigeration output, we must find the refrigeration output QL. So the formula is M times Cp and times delta T. M is mass flow rate, that is we get from the machine 9.5 rpm, and we convert it to kg per second and we get 0.162 kilogram per second, and the Cp that we get is 4.2, and the difference temperature is 6.7 degree. So 6.7 degrees Celsius. So we enter the value at the formula and we get the answer is 4.5586 at kilojoule per second. So to find the overall COP of the refrigeration machine, so by following the formula we enter the value and we get the answer is 1.140. So for the discussion, for this experiment result and data, we need find the enthalpy from the pH diagram to help us get coefficient of performance COP. We have two COP in this result, the COP F refrigerator and COP for heat pump. As we know from the formula, COP of heat pump is equal 1 plus COP of refrigerator. COP of heat pump must be greater 1 than the value of COP of the refrigerator. The COP of heat pump that we get is 7.6 and for refrigerator COP is 6.6. Based on the data we get, this formula is shown to be true by our experiment and data we get. Other than that, the refrigerator purpose is to produce cooling effect, while the heat pump purpose is to transfer heat by circulating a substance called a refrigerant through a cycle of evaporation and condensation.
Conclusion, Based on the result that has been achieved, we can conclude that the difference between the conditioning and refrigeration is heat pump system in the both machines. So the result that occupied determined by the ratio of the heat output to electrical output, which is called as coefficient of performance, which is COP. To get accurate result for the heat pumps ratio, we need some calculation which is Q equal to MCT that determine Q over COP. Conversely, to make an improvement to the refrigeration and air conditioning system, we need some improvement in our COP result. Thank you.